techniques. So we want to look at the separation techniques, their working principles, and possible questions that you can come across as far as those techniques are concerned. Now, in the previous class, when I was talking about examples of physical changes, I made mention that the separation techniques are what? Physical changes. The very first question that you can be asked as far as separation technique is concerned, they can say, which of the following technique is not suitable for separating solid from a liquid? And that is the reason why I have made this such that we can have a list of separation techniques and their working principles. So all we need to do is to look at this list now. So we have the A category. In the A category, we have techniques that we use to separate solid from what? A liquid. We have a solid in a liquid and we want to separate them. We make use of what? All of these what? Techniques. So please make a note of these techniques, just like separation of solid from a liquid. Then all these 7 techniques are applicable. So put those techniques down. You can use filtration to separate solid from liquid, likewise decantation, likewise evaporation to dryness, likewise crystallization, likewise fractional crystallization, centrifugation, and precipitation. So all the techniques listed on the board are used to separate what? Solid from a liquid. So if you now come across a question like, which of the following is not used in the separation of the solid from liquid? Option A, filtration. Option C, crystallization. Option B, centrifugation. Then option D, chromatography. What will be the answer? Chromatography, because it's not in the list of the techniques used for what? Separating the what? Solid from what? Solution. Can we proceed? Hurry up, please.
Yes. Take a look. In this case, of government, in which the head of state is what? Different. Head of states is what? Different from what? Head of government. What is that? Very simple. Head of state different from what? Head of government. Please. Who is head of state? What are you?
Can we proceed?
It is called ceremonial president. What I call it? Ceremonial president. Who is head of government?
The next technique, which is the category B, is used for the separation of liquid from liquid every time. Let's write very fast. Or coming from your friend.
Who was head of state? Who was ceremonial president at that time? What did you say? They don't teach you. Hey, all those things. You don't say you know about American presidential. They don't do exam. Very bad. Now, look at it. The ceremonial president of now he has separated.
Alright, so the next we have separation of liquid from liquid. When we have 2 liquids combined and you want to separate one liquid from another liquid, you can use any of these what? Separation technique from 8 to 10. You can use simple distillation, you can use fractional distillation, and you can use what? Separating funnel method.
And that's what the DP is doing now. Who is the DP of Nigeria? This was
Now, The C part, separation of a mixture of what? Solids. So in this case now, we have solids combined. I want to what? Separate solids. So to separate solids, we can use sublimation, we can use magnetic separation, we can use flotation, we can use what? Sieving. So these techniques that we have outlined here can be used for the what? Separation of mixture of what? Solids.
Now, second republic of France here, 1979, it's the we are talking about presidential system of government.
Are we there? All right. The last category is for separation of colored mixtures, and we have just one under that, and that is what? Chromatography. Chromatography. So each time you see a question that has to do with color or a colored substance, what comes to your mind is what? Chromatography. The word chrome means what? A colored what? Body or a colored substance. Chrome. Right. So now let us look at the technique one after the other. For the techniques, all I'll try to do is to ensure that you see the key points about each technique and areas that you should what? Expect questions from in your forthcoming examination. The first one is what? Filtration. The first one is what? Filtration. Don't write. Don't write. Just pay attention. This technique is used to separate a mixture of an insoluble solid in contact with what? A liquid. That's the most important part. Insoluble means a solid that cannot dissolve in a liquid. Good example, sand. If I have a mixture of sand and water, sand can't dissolve in what? Water. Garri cannot dissolve in what? Water. They will all go into the water and settle at the bottom. Once I have such mixture, for me to separate them, I employ what? Filtration. So you have to know that this is what? The most important thing, what? Filtration. Once you have a mixture where you have a solid that cannot dissolve in a liquid, so what we use is what? Filtration. So put down these points quickly.
You have NBC, you have NBC, you have Midwest Congress, Middle Girls Congress. So when you look at our party, NPN, 2PN, this was like NPP, GNPP, and so on and so forth.
Now, once you get to this point, it's a liquid. Once you get to that point, you climb down to this place. Once you are done here, you climb down to this what? Place. Important for your examination. You climb down to the bottom. This technique can be used in the separation of mixture of chalk dust and what? Water. Chalk dust cannot dissolve in water. It will only settle at the what? Bottom. Unlike salt or sugar, those ones can dissolve in water. Sand, chalk dust cannot what? Dissolve in water. Garri cannot dissolve in water. So they will all form a mixture of liquid and solid. Are we clear about that? So you can use the technique to what? Separate mixture of chalk dust and what? Water. Then, very, very important, you should know where each of the separation technique find what? Application. You can use this filtration in what? Water purification industries and in breweries. You might be asked, which of the following technique find application in water purification industries? The answer is what? Filtration. Are we there? Now, I outlined 2 points, residue and filtrate. You will see what residue and filtrate look like now. Now, let's move on. This is what we do during what? Filtration. You need to get to what? A funnel. Once you get the funnel, you now get a filter paper. A filter paper is what? Round in what? Shape. Then you fold it twice. You fold it first by diameter, then you fold it by what? Radius. It will form what? Something like what? A cone or a funnel. You now push that paper, you wet it with water, you moisten it with water, then you put the what? Moistened filter paper inside the what? Funnel. You now put the funnel on the conical flask. Then here is your mixture of what? Sand and water. You stir with a glass rod and you pour inside what? This place. As you pour here, the water will start dripping what? Out and entering here. All the water you collect here is known as what? Filtrate. While the solid that is left inside here is called what? Residue. So you can write NB, note, nota bene, note. Note. The solid left in the solid left in the funnel. The solid left in the funnel is called residue. The solid left in the funnel is called what? Residue. While the liquid that passes through, is called what? Filtrate. While the liquid that passes through is called filtrate. While the liquid that passes through is called what? Filtrate. Are we clear about that? Now, after filtration, the next technique also works like filtration, but is done in a different way, in a faster way. Before you set up this thing, it takes time. If you want to still separate a mixture of an insoluble solid from a what? Liquid, you can use another method which is faster, but because it is faster, it is not what? Accurate, and that is what we call decantation. What do I call it? Decantation. You can see we said this technique is similar to what? Filtration. However, the solid is of greater what? Density and hence sinks. Right. So then we can see, I don't want us to write stories, just end here. Right from this point up to this point. Then from there we climb down to this place. This part, and you climb down to this place. Are we there, guys? Alright, now each time you want to drink garri and you put your garri in water and you pour out the water, the dirty water from what? The mixture. What you are doing is what? Decantation. So, but you will notice that you are pouring out the water. You can't pour out the whole water. If not, you end up pouring away all the garri, right? So some water will still be left in your garri, and there is no how careful you can be. You must have poured out some garri water as well. So the process is not what? Accurate. You end up losing some of your solid, and you still have some liquid left in the what? Mixture. So that is for decantation, and this is how it is done. For instance, mixture of my sand and water. I'll get another container. I'll put a glass rod here. Then I'll pour gently. The essence of this glass rod is to enable us to know when the water is what? Gone, and we have what? Sand coming out. So once the water is gone and you see drops of sand on the glass rod, you stop what? Pouring. At that point, you have your water here, you have the sand here. But I'm very sure some amount of water will be left here and some sand particles must have what? Entered here. So the process or the technique is not what? Accurate. So in case you are asked, which of the following technique, look at the board now, which of the following technique which of the following technique is not, or it's not suitable? Which of the following technique is not suitable for separating a mixture of what? Solid and what? Liquid. Or which of the following technique is not accurate in the separation of a mixture of solid and liquid? What will be your answer? Decantation. It is never accurate. Next, evaporation to dryness. For this one as well, just take your points from here to here. Now, we are still doing the same thing at this point, but here now, the difference is this. When you put sand in water, sand will not dissolve, right? But for evaporation to dryness, we are using a solid that can dissolve in liquid. For instance, when I put salt in water, so if I have a combination of salt and water, in that case I won't call it mixture, I'll call it what? Solution. So look at the board. A combination of sand and water is called what? Mixture. A combination of what? Sand and water is called mixture. Why is it called mixture? When I look at the combination, I will see the water, and as well I will see the what? Sand, right? So I'm seeing two things. Okay, but in the case of salt and water, by the time I pour the salt in the water, salt water disappears. All I can see is just what? Water. So I call that one what? Solution. So anytime a solid dissolves in the liquid, it forms what? A solution. But if the solid does not dissolve in the liquid, we call it what? Mixture. So in this case now, we use it to separate what? A combination of what? A solid that has dissolved what? In a liquid. So it is used to recover a solid solute from a solution. To recover what? A solid solute from what? From a solution. Now, one thing is this. During decantation, you are pouring the water, right? And you still have your solid. During filtration, you pour the mixture, water passes out, solid is left inside. You still have your solid and what? Liquid. But in evaporation, you will end up what? Sacrificing the what? Water. So that's why this point is there. In this process, the solvent, take note, solute is the solid, solvent is the what? Liquid. The combination of the two of them forms what? Solution. So solute plus solvent forms what? Solution. So in evaporation to dryness, the solvent is usually what? Sacrificed, because we keep applying it until all the water is what? Gone. So take your points up to this place. Are we there? Okay. Now the next thing is this. Before you can decide to use evaporation to dryness for a particular separation, first find out the salt that has dissolved in the water. Is it a salt that can withstand heat or not? If the salt cannot withstand heat, this process cannot be used. If the salt cannot withstand what? Heat, the process cannot be what? Used, because we call it evaporation to what? Dryness. You will keep applying heat until all the water is what? Gone. So if that salt cannot withstand heat, the salt will what? Break down, it will decompose. Are you clear about that? So this technique is suitable for salt that can withstand what? Heat. How do you know salt that can withstand heat? There are salt that have what? High melting point. A good example is our normal table salt. Table salt is what? NaCl. It has a melting point of 801 degree what? Celsius. As such, it can be what? It can be separated by what? Evaporation to dryness. So please, this point also very important. Right up to that point.
200,000.
Then after that, the last part. From here to this point, then the last part.
Very simple. If I know this is yes, when this is next, this is what we have problems here. This is completion, and this one is the water. This one is more here. Like in Nigeria, for example, this election they have, it's not the right thing. Okay, that. I'm not going to mention where it is. Okay. See, I'm not going to election. This of this system, we apply. Or apply this system in the election. What's it? What that is no. You know the what that
we proceed? Alright. So this is what evaporation looks like. You can see that for the first two we have talked about, we didn't talk about heat at all, right? But this one involves what? Heat. Now this is the setup here. The mixture of the salt and water will be inside this what? Evaporation dish. Then you have a beaker containing either water, salt, or oil, or whatever thing you want to use, and you have your heat source here. Now I want to drive out water from this place. Why do I have to put this one in between? Why can't I just eat directly? This substance we have here is called what? A bath. If water is what is inside it, you call it what? Water bath. If it is sand, sand bath. If it is oil, oil bath. Are we clear about that? Now, why do we need water bath? In what? In evaporation process. If I apply the heat directly to what? This evaporation dish, this can what? Blow the what? Flame. At some point the flame come to this side. If the flame should be here, uniform. But at some point the flame can be blown to this side. That means to heat this place more. Water from here will what? Move out more. At some point it moves here like that. That means there will be what? Irregular what? Evaporation. And at the end of the day, some parts will have lost their water. Why will still be having what? Water in some places. So those places that what? Lost their water, as we continue to eat, they're not getting what? Burnt. So in order to ensure that the heat is uniform, you need what? A bath. So as we apply it to the water, the steam from the water will move up and will just heat this place equally, and the water here can move outward at the same rate, and it will get dried at the same time. So the essence of the water bath is to ensure what? Uniform heating. Are we clear about that? Then we use something like a paper around this place. That paper is called what? Paper wedge. What do I call it? Paper wedge. The essence of the paper wedge is to allow for what? Escape of what? Steam from time to time. Why is this so? Why do you think your kettle at home, the cover has two holes at the top? Kettle, the cover of the kettle. When you check the cover, and it by the side at the top, it's something like what? Two holes by the side. I mean, it even has what? A mouth. Even your pot, once you are cooking with the pot, you see steam coming out from the what? Side. Your pot is not having something like bottle that you can tie it, close tight. No, it has space by the side of it so that steam can what? Escape. If steam can't escape, it will build up, create so much pressure, and can what? Explode. So the essence of the paper wedge is to what? Allow for escape of what? Steam to prevent what? Explosion. So now look at this part. I said take note.
If you is 50, I won't be this one. 21.
Take note, the water bath is used to bring about what? Steady evaporation rate, thereby preventing the overheating and splashing of what? Residue. It is advisable to use a water bath when the solvent is flammable. That simply means that if you know, we say what we have here is water and salt. It can be another what? Liquid. It can be petrol or something else. So if whatever you have here is what can what? Easily get what? Or catch fire, you must ensure that what you use here is what? Water. That's a precaution. Then we said on a large scale, common salt is obtained from seawater, pumped into trenches and what? Evaporated under the what? Sun. Just take note of this in your notes. Right. NB. The water bath is used to bring about steady evaporation rate. The water bath is used to bring about what? Steady evaporation rate. The water bath is used to bring about steady evaporation rate. The water bath is used to bring about steady evaporation rate.
Because that's what I have on the whole class. It's going already now. You now understand, say, I am moving on the election.
Yeah, this part. Up to this point.
Because it's working, I know for all of us. Take at least. No, that's why it's 2 words. 2 words must come. 2 words you can say out there.
Now we said to get salt, we what? We pump water from the sea. Sea water contains what? Salt. So to get salt, we pump water from the sea into trenches. Now look at what trenches look like. So you go to the sea, you get water, then you pour water on the wall, trenches, and you leave it there. The sun will eat up the water, and the water evaporates, leaving behind the word salt there. So you can now go back there, skim off your salt, purify it, or enrich it, add iodine, add other things, and then you have what? You have your salt. So this is what will happen eventually. You see your word salt molds form at different regions of the trenches, and that is for evaporation. Next one, simple distillation. Simple distillation. Simple distillation. Now, the very first thing under simple distillation is this. We use it to separate what? Two miscible liquids. That means two liquids that are mixed together. We use this technique to separate them. We separate two liquids that can what? That can mix together. For instance, ethanol and water. These two liquids can mix what? Together. Now take note, you don't just use this technique for two liquids that are mixed together. You must ensure that the two liquids have what? A large difference in their what? Boiling point. You can't use this technique to separate a mixture of benzene and ethanol. The boiling point of benzene is 80 degrees Celsius. Ethanol is what? 78 degrees Celsius. You can see they have close boiling point. So simple distillation cannot be used to separate what? Mixture of what? Benzene and what? Ethanol, because they have what? Close boiling points. So you must ensure that the liquids that have mixed together have what? Far what? Boiling point what? Difference. For instance, ethanol and what? Water. 78 and what? 100. So we can use the technique to separate what? Mixture of ethanol and what? And water. So pick up the notes up to this point.
Wow. That's what they call it. That's the charm. No matter how progressive and the matter that progressive, because when they progress, they go out. Imagine how they was better. That's why I say, you look like this. Look how pure. That's what we like. Look how pure.
Are we done?
Are
we done? Alright, now this is what simple distillation looks like. We have our mixture here of, let's say for instance, ethanol and water. So what? Start to apply it. Then we are monitoring the what? Temperature using our what? Thermometer. As we continue to what? Apply it. Once the temperature reaches 78 degrees Celsius, which is the what? Boiling point of ethanol, ethanol will become vapor and will rise up. Then will enter this place. By the time it gets to this place, it will be cooled. When it is cooled by the water entering here and moving out of here, it will be cooled by the water and it will change from what? Vapor to what? Liquid. And then what? Get to this place. Are you clear about that? So that liquid that we collect on this side is called the what? Distillate. Then water will be left what? Here. Then we have what? The other one there. Now the reason why the boiling point should not be closed is that if one is 78 and the other is 80, the difference between 78 and 80 is not so much. So while ethanol is still evaporating, benzene will evaporate after it, and you still end up having mixture of what? The two of them on that side. That is the more reason why they should have what? A large what? Boiling point what? Difference. That's an important point for you to what? Take note of under distillation. So That one is fractional distillation because it involves 2 or more liquids. Now, take note of this last point under distillation. Distillation is used in gin distilleries and water distilleries for the manufacture of gin and distilled water.
In election normally, so that we call 1, 2 and 3. Every election, there must be 3 words, 3 major particles or fights. Now this is what. If this gets this now, we'll be surprised us in this place. And that's why I say it now. Other parties come and they share their opinions. So we say no, we'll be better to the man. Now normally, the previous election was a man from the party, a woman. It was 4 candidates. I think it was Buhari, Atiku and then that would something like this. So this is PP and what is that? MC does their call. Normally then.
Are we there? Alright, so take note, the application, gin distilleries out. Before a particular separation technique, it means it is similar to that previous one. It is just like ordinary what? Distillation or simple what? Distillation. But in this case now, we are having more than one what? Liquid. We are having what? Several liquids. In that previous one, we just have what? Water and ethanol. But in this case, we are having like 3, 4, 5, 6, 7 what? Liquids. All mixed together. So we use what in that case? Fractional distillation. So this is used to separate, it's still the same concept. The same concept, and don't forget the same thing is here. So just right, this is similar, let's write, this is similar to simple distillation. This is similar to simple distillation, but it involves many liquid mixed. But it involves many liquids mixed. But it involves many liquids mixed. Then after that, you jump to this part. After that, you jump to this part. In the laboratory, the apparatus of fractional distillation is similar to that for simple distillation, except that a fractionating column is introduced. Except that a fractionating column is introduced.
Very useless man. So when I to the States, see what is like extra? What they call extra? It's like extra. That's what they don't try for them. They don't say, I'm not going to be they send this money to the States. They send this money. They send this money. If for some reason they are if not, they do like it. If I have to be a colleague, they call it woman. That's what they call woman. Anything, not anything. I hope you read the States. I was like, again, you see one that I don't see that.
I will there.
Right? And that's why they don't say that.
A fractionating what? Column. Now, a fractionating what? Column. Now, take this part. Take this part. After fractionating column, full stop. Then you write, the fractionating column is packed with glass what? With glass beads, which do the actual separation. The fractionating column is packed with glass beads, which do the actual separation. The fractionating column is packed with glass beads, which do the actual separation.
singing. And based on as they do get mass, because we prefer a more, and that's the first category. That's why every time all those
Alright, now from what we have seen, it means if we look at the setup for ordinary distillation and we look at the setup for fractional distillation, just one thing has been introduced. This part. Are we clear about that? Precisely at this region here. Precisely at what? This region here. So this part here is what has been introduced compared to this other one. Can you see that now? In this place, you don't have that. But here, we have what? We have it. So this is what? That's the fractionating what? Column. So in case you are asked, what differentiates fractional distillation setup from simple distillation? What is the answer? Fractionating column. Are we clear about that? The fractionating what? Column. Separate simple distillation from what? Fractional distillation. And take note, if you want to separate, we said that here, fractional distillation can be used to separate the various components of what? Crude oil. So just write in your notes, it is used to separate the components of crude oil. It is used to separate the components of crude oil. It is used to separate the components of crude oil.
In this life, what is having influence in life? Influence in our mind. We have influence. Even though you need something useless, that's what we need to say.
Are we there? Alright, so fractionating column is very important in fractional distillation, and there is separation of the components of crude oil. Another name for crude oil is what? Petroleum. Thank you. Next, chromatography. Chromatography.
In which
chromatography.
In which the number of seats that a party has. In which
chromatography. He said this is used to separate a mixture of solutes. It can also be used to separate colored substances, e.g. ink, pigments, and dye, as well as colorless complex substances, e.g. amino acids.
There's a program called Lagos Parliament. I'm looking at the what's no government, what's for news. I'm going to line that down. What is your great stars? And what are the progress? No one's going to hang out. No one's going to hang out. Guys. No, I said no. What is it? Yes. So listen, you won't keep doing that. There is no one going to be.
Are we there? Are we at this point? Alright, now, during chromatography, what we do is very simple, and it's very important to note the point. What we simply do is this: you get a colored substance, mixture of different colors. For instance, red, blue, purple, and so on. You mix those colors together. Then you put a drop of those mixtures of colors. You put it towards the end of this paper. Then you dip the paper into what? A solvent. But you ensure that the place where the mixture is doesn't enter inside the word solvent. For instance, if the solvent is up to this level, I'll put my word mixture. I'll put my mixture on this side. Now, by the time I dip the paper into the solvent will start moving what? Up the paper. As it is moving up the paper, it will be dissolving the word colors, and the color too will be what? Moving. You can see the colors will be what? Moving as well, but the colors will be moving at different what? Speed, so that at the end of the day you can have one of the color, which is for instance blue, to have moved faster or fastest, and it's at the way top, while purple is of average speed and the slowest is what? Red. All the way from this point you can see red has moved to this point, purple from here has moved to this point, then blue has moved what? Up to this point. So that means in this separation technique we have what? The solute moving at different what? Speed. So you can write in your notes NB notes. This technique is based on the ability. This technique is based on the ability. Note, this technique is based on the ability of solute. This technique is based on the ability of solute to move at different speeds. Of solutes to move at what? Different speeds. When they dissolve in giving solvent, when they dissolve in giving what? Solvent. When they dissolve in giving what? Solvent. So that means that, now let me explain another point to you. This one that has moved fastest, which is the blue, is the one that has what? That is the what? Most soluble. And at the same time, also the what? Fastest. Why the one here is the least soluble and the what? Slowest. So when you use of chromatography quickly. Uses of chromatography. Uses of chromatography. Number one, it is used in petroleum industry. Petroleum industry to separate the what? Constituents, to identify, note that. We have mentioned petroleum in today's class 1 hour before now. When was that? Under fractional what? Distillation. So take note, fractional distillation is used to separate the components of what? Petroleum. While chromatography is used to what? Identify the components of what? Petroleum. So when you see a question about petroleum, don't be in the age to answer it. Check. Is it for separation or for what? Identification. Right. Are we done? Number 2. It is used for blood and urine analysis. It is used for what? Blood and urine analysis. You want to check the components of the blood or the components of the determine the amount of preservatives present in what? Food. Once you are given a question under separation technique and you mention anything food, the answer is what? Chromatography. You mention anything food, the answer is what? Chromatography. You mention anything blood analysis, the answer is what? Chromatography. Urine analysis, the answer is what? Chromatography. Identification of the components of petroleum, the answer is what? Chromatography. Are we done with that? Sublimation. We have once talked about sublimation, yes or no? We said some solid, when we apply it to them, they will not become liquid. They will what? Get what? Straight onto what? Gaseous state. Such solids are known as what? Sublimable what? Solids. A good example is the iodine, right? Okay, now, anytime you have a mixture of two or more solids, where one of them can sublime, the separation technique we are going to use is what? Sublimation. Now, take note of the word that we have here, volatility. Volatility simply means ability to what? Change to gas. Are we clear about that? So that means solids that can sublime are highly what? Volatile. So in case you are now asked, what separation technique can be separate mixture of solids? Where one is what? Highly volatile. What will be the answer? Sublimation. So this technique is based on the relative volatility of the constituents of solid-solid mixture on it. On the table, you see something like what? Smoke. I mean, now that is what? Vapor. The ice is what? Solid. What's coming from it? Vapor. What is vapor? Gas. Solid to gas. That is what? Sublimation. Then we have iodine, we have benzoic acid, and other substances. So these are so anytime we are giving a mixture and it involves one of these guys, don't do that at all. What we apply is what? Sublimation. As simple as that. Let me proceed. Next. sublimation. And you can see what is happening here. This is a description of what? Sublimation. You can see solid becoming what? Gas. From solid to gas. Without what? Getting to the liquid stage. That is what? Sublimation. Next technique is what? Flotation. 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 Just right up to this point. That's the important part for now. Just right from here to here, then jump to here. From here to here, then jump to that part. That was flotation. Solid or substance is hydrophobic, and the ones that like water are what? Hydrophilic. So we use flotation to separate what? Hydrophilic from what? Hydrophobic substance. And we can use it for separating metallic salts from their earthly materials. Example of earthly material is sand. From their earthly impurities. It is the earthly material that will serve as the what? Hydrophilic. While the metallic ore is the what? Hydrophobic. So the hydrophobic one will go to the what? Top. Are we clear? While the hydrophilic one will stay at the what? Bottom. See the illustration. If you are separating metallic ore from what? Earthly material, we have metal and we have what? Sand. Are we together? By the time we have this combination, this one is what? Water loving. This one is what? Water fearing. Why is this water loving? Because water can wet what? Sand. I mean, but water cannot wet what? Metal. To pour water on metal, can only wet metal. blood. Alright. Now, some forms of crystallization are pure. They are what? Whenever purity is of what? Importance. Are we clear about that? So we said what? Some form by crystallization are always what? Pure. Not only that, they usually contain what? Water of crystallization. That example on the previous slide, what's the example? Copper, sulfate, 0.5 pentahydrate. This is water of crystallization. So most of the stuff that we derive by crystallization, we always go along with what? Water of crystallization. Then number 3, it is based on the what? Relative solubility of all different solids at different temperatures. Are we clear about that? It is based on what? Solubility. So like I said, by the time we do, now I want to say the crystallizing was out. So the crystallizing out gradually after what? After putting the what? Solution. The one that is more soluble will remain in the what? Solution. When the least soluble one will crystallize outward faster. Why is this so? Solubility of a solid is inversely proportional to what? Temperature. Pardon me, this is what? Direct proportional to temperature. What meaning of direct? That means the higher the temperature, the more the what? For instance, when you put starch in water, some starch won't get enough to water, but it must increase what? Temperature. Yes or no? Yes. It's a mixture of compounds and not a single colored compound. I told you, anytime it has to do with what color, what's the answer? Chromatography. Option E. Then look at number 6. Which of the following compounds and elements? Which of the following compounds and elements would sublime on exposure to what? Atmosphere. Which of the following compounds okay, you can see ice in the option. You can also see what? Iodine. So what will you go with out of the two? Iodine is one of them, right? I love ice there too. The more appropriate answer here is what? Iodine. You mentioned what? Elements. Ice is not an element. Iodine is what? An element. And by the things as well, also in the molecular world state, when we combine several forms of it. But basically, with this element that answers to the question, that is looking at the more appropriate answer. Thank you so much. Evaporation. Question 9, without thinking for so long. Question 9. Okay, is it question 8 or 9? That should be question 8. That's question 8, yeah. Question 8.